Welcome everyone to Decode ITES. This is a single learning platform for multiple IT infrastructure technologies. Do like, share, and subscribe to our channel. Let's have a small introduction of myself. My name is Prince Garg. I'm having 3 plus years of work experience. I have worked on Red Hat, VMware, Windows, Google Cloud, PowerShell, Python, and Bash scripting. You can reach out to us on ITES Fun Facebook page, or you can reach out to me on Instagram at b_limitless, or you can follow me on LinkedIn by prince-garg-ites, or you can visit our website itesfun.com. Welcome back everyone to the learning series of Linux 8 and the Decode ITES. In this lesson, we will gonna talk about the IP tool in Linux. Let's continue. So the IP command is a Linux net tool for system and network administrators. IP stands for Internet Protocol, and as the name suggests, the tool is used for configuring network interfaces. Older Linux distributions use the ifconfig command, which operates similarly. However, ifconfig has a limited range of capabilities as compared to the IP command. Understanding the IP tool. The IP tool can be used to manage all aspects of networking, like the IP networking. It replaces the legacy ifconfig tool, and I would suggest do not use the ifconfig anymore. Using the IP addr to manage address properties. These are the command. Use IP link to show link properties, and use IP route to manage route properties. Let's take a look at the practical overview session, and I will guide you with some basic commands and will clear out your doubts. So let's start with the IP link show command. IP link show. This command will show current network configuration, which basically is just a list of network device names. This is useful if you want to figure out which devices you have got on your system. We can also use it in a slightly alternative way, like IP -s link show. The difference is that IP-S link show is showing statistics about the link as well. And the statistics are right here. So this information probably we should check it here on the real network card. This information is providing information about the received packets. RX stands for the receive and TX stands for the transmit packages, as you can see over here, RX and TX. You can see how many bytes, how many packets, how many errors, how many dropped overrun, multicast, and collisions over there. This information is interesting if you are on a network that is not completely reliable, because this information is telling you exactly what is going on and will indicate whether or not you are experiencing any problem on your network. So if you want to manage IP address configuration, then we have IP-addr. The first command that you need to understand is IP-addr show, as it will show you current network configuration. So we can see if the NIC name ENS 192, which is my network card. What else do we see? Well, some of the network card properties. These are technical properties that don't really matter for what we need to know here. Here we can see the MAC address of the network card. That's the unique identifier of this specific network card. And we can see the INET address. This is the IPv4 address that we have been talking about. Also interesting is that if we can see that this IPv4 address is dynamic. It's a dynamically assigned IP address. And that means that the IP address was assigned by a DHCP server. So you don't need um, anything else, and you need a DHCP server in your network in order to get a dynamic IP address. If you are in situation where you don't see anything at all, then it might be possible that your system doesn't have an DHCP server. We'll talk about that later. DHCP servers give you an out IP address for a limited lifetime. Here we can see the valid lifetime in total. Also, we can see the INET6. This is the IPv6 address. If you can see over here, this is the IPv6 address which is written over here. IPv6, something interesting is happening because every network interface card gets an IPv6 address that is for internal use only. If you don't see an IPv6 address that starts with FE80, it's like a private IPv6 address. So you cannot get out the internet with this type of addresses. But the address automatically assigned as IPv6 has become the default get out into the internet and the protocol if every node in the network has an automatically assigned IPv6 address. At least the nodes internally can talk to one another. That's the idea behind it. Notice that behind the IPv6 address, we can see the scope link. And the scope link means that it is a link local address when it is not a routable address. Compare that with the scope global on the INET address. Scope global means that this is the worldwide valid IP address that allows you to go out into the wide world. So what else do we need with IP command? We might want to know like how to add an IP address. So that will be IP space addr add dev ens33. As we are having ENS192, we would use ENS192 and then the IP address which we would like to assign over here, like 192.168.37.137/24. IP address, when you see the IP address, you will need to specify the device. So dev ENS33, or here we have mentioned ENS192, and we need to specify the IP address that you want to add. As I'm using this range of IP address, I've mentioned the same. And notice that with this command, I'm adding a secondary IP address. Secondary IP address means that at this point, I should have two IP address. If you can look, there we go. Like with this IP address, the scope of global has been added to ENS33. So I can even ping it at this point. Let's try to ping the same. We can see it start to ping. Okay, adding adding a secondary IP address is useful in some specific environments. For example, container host may need it to make sure that every container has a unique IP address. Cloud hosts may need it. Web servers may need it, especially if they are hosting different websites. Do notice that if you are using IP address to add IP address this way, it is runtime. And runtime means that if you reboot or even shut down and bring up your network interface card again, the IP address will be gone. There's also a nice time to talk about the command that should not use anymore, which is ifconfig. As it's showing, the command is not found. The command became obsolete after releasing RHEL 8 version or the Linux 8. So the next command which we're gonna talk about is IP route show. It is showing the current routing table where we can see that the default route is 192.168.37.136. So that's my default router's IP address. So if I use ping 8.8.8.8 to go out on the internet, it's using the default router. Not do something funny. IP route del default via route, this one. And like, let's try this command. IP route del default via 192.168 37.137. As it's showing us to duplicate or it's a garbage. Okay, and now the system has a default route again. Let's clear out the screen. So the system has a default route again and we can get out to the internet. Now there is one more part that is involved in setting up a runtime network configuration, and that is DNS. DNS is managed through a configuration file. So you cannot do that easily on the command line. What you can do is change the content of the file. If we look at the file cat etc resolve.conf, you can see the file is generated by Network Manager. And you should realize that behind all these there is a Network Manager servers, which I will explain about next. But the thing you should realize now is that every time the Network Manager server restarts, it recreates this file. So it makes no sense to editing it unless you want to try out runtime if the intended configuration works. In that case, you do change the content of this file, and if it works, you may make it persistent. So Network Manager, and next time when you restart your computer or the network interface, the Network Manager will write everything again. And that is how you manage networking in a runtime. So that's all for this lesson. I hope you have understood well. If you are having any queries, you can reach out to us on itsfun.com or drop a comment in the comment section below. Thank you.